Hi, this is Professor Gina, and this is the second part of the lecture examples for section 8.3. In the last video, we were looking at taking a trigonometric number and raising it up to a power. Now we're going to go in the opposite direction, which is to find the roots. We'll do an example of finding a square root and a cube root. So we need to start with a theorem. The nth root, and meaning it could be any number, of a trigonometric value, r cosine theta plus I sine theta, is we take the absolute value when we raise it up to, and if we're taking a square root, that would be to the square root of, or the cube root of, right? When you take 1 over a number, like 1/2, that means the square root. And then as far as the angle is concerned, we divide the original angle by the number of roots that we're trying to find. And then I'll talk about this part that's added on here in the end. We add on a particular angle value to find the other roots. I'll give you an example in just a second. The easiest way to do this is to find the first example when k is equal to 0. When k is equal to 0, this part is non-existent. And so what we're really doing is we're taking the angle and we're dividing it by the number of roots we're trying to find. If we're trying to take square roots, that would be 2 roots. If we're taking cube roots, that would be 3 roots. And then what we do is we figure out how far apart those angles are spaced, and we would add, this part here is adding the number of degrees to space them out evenly. So if we have square roots, for example, there are only going to be 2 of them. And if one of them is here, the other one is going to be 180 degrees away from that first angle. If we are finding, let's say, cube roots, there would be 3 of them. So if the first one is here, the next one would be here, and then the last one would be here. They're all going to be 120 degrees from one another. And then if we're finding, let's say, 4th roots, they're all going to be 90 degrees away from each other. So if one is here, one is going to be here, one is going to be here, and one is going to be here. They're all going to be evenly spaced out. So what I'm suggesting is that we just find the first angle, which is that theta over n, and then we can find the other angles by adding the appropriate degrees. So let's do an example. Let's find the square roots of negative square root 3 minus I. There should be 2 of them, and whatever answers we get, if we square those numbers, we should get this number negative root 3 minus I back. So using the theorem that we had above, we need to first change this into trigonometric form. So we'll find r, which is the square root of a squared plus b squared, or negative root 3 squared, and then plus minus 1 squared. So that'll be 3 plus 1. Looks like in this case, r is going to be equal to 2. And then we have to find the angle. Based on what we're given here, it looks like we're in the 3rd quadrant. And we have this distance is negative root 3, and this distance is negative 1. And then we said that this distance is 2. So the sine of the angle is -1/2, and the cosine of the angle is -√3/2. So putting those two things together, I think that the angle is 210 degrees. So the original that we were given was, we're taking this number and we're raising it to the 1/2 power, which means taking the square root. So instead, we're going to rewrite it as 2 cosine I sine 210 degrees raised to the 1/2 power. We're going to write it in trig form instead. Now, the theorem we had above said that we would take the absolute value, or 2, and we would raise that to the 1/2 power. That's the same as taking the square root of it. And then we're going to do the cosine of 210 degrees divided by 2 plus I sine 210 degrees divided by 2. This is our first root. The second root is going to be the same, but we're going to add 180 degrees to whatever the angle is, because we know that these two are going to be spaced 180 degrees apart. I'm just showing you the systematic way to find the angles rather than plugging in k = 0 and k = 1 in this case. So what we have here for the first root, square root cis 105 degrees, right? This is one of our solutions. And the other one is going to be 105 plus 180. So our second answer is the square root of 2 cis 285 degrees. So again, if you find the first angle by taking the original measurement and dividing it by the number of roots you're finding, you can get the other ones by just adding the number of degrees. I'll do a different example that'll show you for, let's say, cube roots. Okay. Let's find the cube roots. So we'll find 3 of them this time, of 1 minus the square root of 3 times I. So the first thing that we'll do is change this into trigonometric form. This is going to be in the 4th quadrant, right? We've got 1 here and -√3 here. So R is going to be 1 squared plus -√3 squared. This is also going to be 2, right? So looks like the length of our hypotenuse here is 2. And then we need to figure out what the angle is here. I know that the sine of the angle is -√3/2, and the cosine of the angle is 1/2. So I think the angle is 300 degrees. So what we're trying to find instead is 2 cis 300. This is the trig form of the complex number that I had to start, and I'm raising it to the 1/3 power. That's to find the cube roots. To do that, I take 2, and I'm going to take the cube root of it. And then I take the angle and I divide it by 3. So I'm going to have cube root of 2 is this 100 degrees. That's my first answer. Now, if I take 360 degrees and I divide it by 3, that's going to be 120. So that's each angle, each root is going to be spaced by 120 degrees. So for my second answer, I'm just going to add 120 degrees to the angle that I had. So I'll have 220 degrees. And then for my third root, I have cube root of 2 and adding another 120 degrees, I get 330 degrees. So these are my 3 answers. I want to go back now and I want to check one of the answers that I had above for the square root. Actually, I'll go to a separate piece of paper for this. Let's check answer for square root, so you can understand what's happening behind the scenes. The original problem that we had was we were asked to find the square roots of this number. And the answer that we got, I'll just pick one of them, was square root of 2, this 105 degrees. Meaning square root of 2 times the cosine of 105 degrees plus I times the sine of 105 degrees. If I plug this into my calculator, I have the square root of 2 multiplied by the cosine of 105 degrees is negative square root of 6 plus the square root of 2 over 4. And the sine of 105 degrees is square root of 6 minus square root of 2. No, wait, plus over 4. So this is the sort of the written out version. And what this is saying is that if I take this value and I square it, I should get this. And that looks really far from what it is, doesn't it? So that's what we're going to do. We're going to square this and see whether we get that original thing back. So I'm going to do this in phases. Oops. The first thing to kind of think about is that if I have two things that are multiplied together and I'm squaring them, I can think about them separately. And what I mean by that is I have two things. I've got one thing here multiplied by this whole thing here. And because I'm trying to square this entire thing, I'm going to square them separately. This first part is super easy, right? When I square this, I'm just going to get 2. So we'll leave that off to the side. This part on the inside, though, is the part that's complicated. And I've got two things added together, and this follows the pattern of A plus B squared, which would be A squared, squaring the first term, plus 2ab. I multiply the two things together and double that. And then I square the last term. So I'm going to skip a few of the steps, but just sort of show you what ends up happening as we do this. You can do this part on your own. I think you can do a lot of this in the calculator as well. If I square this first part, -6, negative root 6 plus root 2 over 4, this part squared, I end up getting 2 minus the square root of 3 over 8. If I square that second part, that's a negative. It's kind of hard to see. The second part, the b squared, if I square square root of 6 plus square root of 2 over 4, that part squared, I end up getting 2 plus the square root of 3 over 8. Those are similar, just one's got a plus, one's got a minus, right? But this second one is multiplied by I. And so when I add the I squared part there, I squared is equal to -1, right? So this part actually becomes the negative. This changes, this whole thing has a negative in front of it, right? Because the I squared is attached to that. It's kind of interesting because it looks like some things are going to cancel when I put these together. And then the last part, which is the most complicated, is multiplying the two of them together and doubling it. So I have 2 multiplied by negative root 6 plus root 2 over 4 times I square root of 6 plus square root of 2 over 4. Right? This whole thing is multiplied together. Whole lot of things cancel when you do this. And you end up with 2I negative 6 minus root 12 plus root 12 plus 2 over 16, which will eventually boil down to -I over 2. So when we put all of these three components together, we have a 2 from way back up here in the orange, right? We had a 2 out in the front and we squared that square root. So we have 2. We have 2 minus the square root of 3 over 8 minus I over 2 plus 2, actually, this is a -2 minus the square root of 3 over 8. So again, this is the a squared part. This is the plus 2ab part, and this is the plus b squared part. And so a bunch of things are going to cancel. We're going to have this +2 and this -2 cancel. We're going to have this and this double up. So I'm going to end up with 2 on the outside. I'm going to have -2 times the square root of 3 over 8. Is that right? Minus I over 2. Hang on one second. I think I have an error. Let me pause for 1 second. Right, I found my error back. It just has to do with the denominators. So when I squared over here, this should be over 4. This shouldn't be an 8. These should be 4s. So let me scroll again. So this should be a 4. Okay, then I end up with 4 here. Yeah, that makes sense. Because then I get distributing the 2 to both of these items. I'm going to get -4 root 3 over 4 minus 2i over 2, which is -√3 minus I. That's what I started with back at the beginning. And when I took the square root, I got that crazy number that we had way above. The number that we had was cosine of 105. And what I did was I took the cosine and the sine of those numbers, squared them, and I end up getting that original number back. So this is just a lengthy way to show you that the theorem we're using actually works. All right, let's go back and do one more example. In this example, we will find 4th roots. So let's see, I'm going to go back up here. And let's find the 4th roots of I. So we're trying to find I to the 1/4 power. We know that these roots are all going to be 90 degrees apart, right? They'll be spaced by 90 degrees. And I start by writing this as a trigonometric number. I is going to be right here. So if I want to consider I to the 1/4 power, writing it in trig form, the distance from the origin to I is just going to be a distance of 1. So R is going to be 1, and the angle is 90 degrees. So I'm thinking about this raised to the 1/4 power. The theorem says that we can take the R value, and in this case, take the 4th root of it. And then for my first angle, I'll take the original angle, 90 degrees, and divide it by 4. So 1 to the 1/4 power is just going to be 1. And then our first angle is going to be 22.5 degrees. So this is our first answer. Our second, third, and fourth answers are going to be the same, but we're going to add 90 degrees to get the other answers. So that would be, if we add 90 degrees, that'll be 112.5, and then 202.5, and 292.5. So those are our 4 answers. All right, so that is the end of section 8.2 or 8.3, and then I'll make another video for polar graphs for 8.4. Have a great day.